One,
Mm-hmm.
the basics, the setup. The sources are really clear that the first mistake people make is jumping straight to what do we need to do without figuring out how they're even going to schedule it.
Right. You need the schedule management plan. I know it sounds super bureaucratic, but think of it as the constitution for the project. It sets the laws.
Okay.
What software are we using? Is it Microsoft Project? Are we just using Excel? How do we measure progress? If I say I'm 50% done, what does that actually mean?
That is huge. Because
Wow.
if I think 50% means I started and you think 50% means I'm halfway through writing the code, we have a massive problem.
Exactly. The plan standardizes the language. It also defines your variance thresholds. You know, how late does a task have to be before we sound the alarm? If you don't write these rules down first, you're just making it up as you go.
Okay, so we've got the rule book. Now we figure out the work. And this brings up a concept I see everywhere in these notes: decomposition.
It's a great word.
It sounds kind of grim, but it's essential. You take the big, scary project scope, the work breakdown structure, or WBS, and you just smash it into smaller and smaller pieces.
Right. Until you can't smash it anymore, you break it down into what are called work packages.
Because you can't schedule build a skyscraper.
No, it's too abstract. But you can schedule pour foundation level 1. Decomposition turns a big vision into, actionable steps.
And once you do that, you end up with a few lists. The sources highlight 3 specific outputs here that seem distinct but are totally related. You've got the activity list, the activity attributes, and the milestone list.
Think of them as just layers of detail. The activity list is the menu, everything we need to do, just the list. The activity attributes are the ingredients list for each item, who's doing it, where is it happening, what are the constraints. It's all the metadata.
And milestone list.
Those are the zero duration items. They aren't work. They're moments in time.
I always think of these like save points in a video game. You don't do the save point, you reach it.
That is the perfect analogy. It's a flag in the ground, permit approved, design signed off. It tells stakeholders you've completed a major phase without forcing them to read the 500 little tasks it took to get there.
Now, there's a strategy mentioned here called rolling wave planning. And I want to dig into this because it feels like a license to not plan everything right away.
It's not laziness, I promise. It's realism. Rolling wave planning just says, plan the near term in super high detail down to the day, maybe even the hour. But for work that's 6 months out, keep it high level.
A big bucket.
Just a big bucket. Because if you try to plan next December's work on a daily basis today,
You're just guessing.
you're just guessing, and you'll be wrong. And then you'll have to redo all of it. This prevents analysis paralysis. You plan the wave you're surfing now, and you wait for the next wave to get a little closer before you detail it out.
Smart. Okay, let's move to phase 2, sequencing. We have our list of tasks. Now we have to play connect the dots.
This is drawing the map. We use something called the precedence diagramming method, or PDM. Visually, it's just boxes or nodes representing tasks connected by arrows that show the logic.
And the logic isn't always that simple. The sources list 4 types of relationships between tasks. The standard one, the one everyone knows, is finish to start.
Right. Task A must finish before task B can start. You have to pour the concrete before you can frame the walls. 90% of your schedule is probably going to be this.
But then it gets more nuanced. You have start to start and finish to finish.
These allow for parallel work. Start to start means I can't start my task until you start yours. Imagine a security escort. I can't start walking through the secure facility until you start escorting me. We have to go together.
And finish to finish.
I can't finish my task until you finish yours. Think of writing a report and editing it. The editor can be editing while the writer is still writing, but they physically cannot finish the editing process until the writer finishes the writing process.
That makes sense. But there's one that always trips people up. Start to finish.
The SF relationship, it's the weird one, the rarest one. The successor task cannot finish until the predecessor task has started.
Which just sounds backward. I can't stop until you begin.
Okay, think of a shift change. I'm the night guard, so I'm the successor. I cannot finish my shift and go home until the morning guard, the predecessor, has started their shift. If they're late, I'm stuck. My finish depends on their start.
Okay, that finally clicks. Now, what dictates these connections? Is it always like physics?
No, and that's a crucial distinction for a project manager. You have mandatory logic or hard logic, that is physics. You can't put the roof on before the walls. But then you have discretionary logic or soft logic.
This is where we simply prefer to do things in a certain order, right?
Exactly. We prefer to paint the walls before we put in the carpets. We don't spill paint on it, but we could do it the other way if we had to. Knowing the difference between hard and soft logic is your superpower later on when you need to compress the schedule.
Because you can break soft logic.
You can break soft logic. You can't break hard logic.
And you definitely can't break external logic either.
Nope. That's waiting for the government permit or the vendor delivery. You are at the mercy of the universe on that one.
Before we leave sequencing, we have to talk about the accelerator and the brake. Lead and lag.
Think of these as modifiers on the relationships. Lag is waiting time. It's the brake. You pour concrete, you need 3 days of lag for it to cure. No work is happening, but the clock is ticking.
At lead.
Lead is the accelerator. It's an overlap. So if we have a finish to start relationship, say, writing code and testing code adding lead means we let the testers start a few days before the coders are totally done. We get a head start.
Okay, so we've got the map. We know the order. Now we enter phase 3, estimating. And this is where the notes get really interesting because this is where the math meets the human brain.
This is the danger zone.
Why is it so dangerous?
Because humans are, frankly, terrible at estimating time. We're optimistic by nature. We assume everything will go perfectly.
So how do we fix that? The sources list a few techniques. We have analogous estimating.
That's looking at history. The last website we built took 3 months, so this one will take 3 months. It's fast, but it's really rough. It assumes this project is exactly like the last one, which it almost never is.
Then there's parametric estimating. This feels a bit more scientific.
It is. It's statistical. It takes 1 hour to lay 10 bricks. We have 1,000 bricks, therefore 100 hours. It's scalable and accurate if your work is repetitive.
But for complex, messy work, the gold standard seems to be bottom up.
Yeah. You go back to that WBS, you look at every single tiny work package, you estimate them individually, and then you roll them all up. It takes forever to do, but it gives you the most accurate number.
But even then, a single number, this will take 10 days, is usually wrong. This is where three-point estimating comes in, also known as PERT.
Program Evaluation and Review Technique. I love PERT because it forces you to acknowledge reality. Instead of one number, you give 3. Optimistic if everything goes perfect, pessimistic if everything breaks, and most likely,
And you just mash them together?
you use a weighted average. It's called the beta distribution. You give the most likely number more weight, usually times 4, add the optimistic and pessimistic, and then divide the whole thing by 6. It gives you a number that respects the risk.
Speaking of risk, let's talk about the safety nets. Reserves. There are 2 buckets here, and mixing them up seems like a really common mistake. Contingency reserve versus management reserve.
Here's the litmus test. Is the risk specific? Do we know about it? Contingency reserve is for known unknowns.
Known unknowns. That sounds like a riddle.
It just means we know it might rain. We know a key supplier might be late. We put time aside specifically for those identified risks. It is part of the schedule baseline. The project manager owns this time.
And management reserve.
That is for the unknown unknowns. The asteroid strike. The company gets acquired. The global pandemic. You can't plan for the specific event because you don't even know what it is. This is a bucket of time held by senior management, not the project manager. You have to ask permission to use it.
Now, why do we even need all these reserves? The sources list some great behavioral theories that explain why we're so chronologically challenged. The first one is a classic, Parkinson's Law.
Work expands to fill the time available for its completion.
Oh, this is painfully true. If I give myself a week to clean the garage, it takes a week. If I give myself a Saturday morning, it takes a Saturday morning.
Exactly. If you pad a schedule with too much buffer, people won't finish early. They'll just polish the work or slack off until the deadline hits.
Which leads right into student syndrome.
We all did this in school, right? You have a paper due in a month. You start now? No. You start 3 days before. You wait for that urgency to kick in. In project management, this just destroys any buffer you built in because any unexpected issue at the very end will make you late.
And then there's the law of diminishing returns.
This is the mythical man-month concept. If a project is late, adding more people often makes it later.
Because of the ramp-up time.
And the communication complexity. If you have 2 people, there's 1 line of communication. If you have 5 people, there are 10 lines. You throw 20 people at a late project, they spend all their time talking to each other instead of actually working.
Okay, so we have our estimates, and we've tried to account for our own bad habits. Phase 4. Developing, we plug all this into the machine, and we find the dates. And the star of this show is the critical path method, or CPM.
This is the absolute heartbeat of the schedule.
So define it for us. What is the critical path?
It is the sequence of activities that represents the longest path through the project.
Wait, I want the project to be short. Why am I looking for the longest path?
Because the longest path determines the shortest possible duration for the whole project.
Okay, walk me through that. It sounds completely contradictory.
Yeah. Okay, imagine a relay race. But also, imagine someone else is running a separate, shorter race next to you. You can't leave the stadium until everyone is done running.
Right.
Path A takes 10 minutes, Path B takes 20 minutes. It doesn't matter how fast Path A runs. The group is stuck there for 20 minutes. Path B is the critical path. The project cannot finish until that longest chain of events is complete.
So if I'm the project manager and I want to finish earlier, looking at Path A is a total waste of my time.
Purely a waste of time. You have to focus all your energy on the critical path. That is the only place you can buy back time for the project.
And the paths that aren't critical, they have float or slack.
Right.
Yeah.
They have that wiggle room. Total float is how much you can delay a task without delaying the project finish date. You can take a long lunch, and the project still ends on time.
But there's also free float. What's that?
Free float is a bit more selfish. It's how much you can delay your own task without delaying the very next person in line. I can be late, but I won't make you late.
And then there's the scary one, negative float.
That is the siren going off. Yeah. Negative float means your calculated finish date is already after your required deadline. You're already late before you've even started.
And before we talk about fixing that, the sources mention one more advanced way to look at dates. Monte Carlo simulation.
This is for when the simple math just isn't enough. You use a computer to run, like, thousands of iterations of the project. It mixes all those pair estimates, the optimistic, the pessimistic, and it generates a probability distribution.
So instead of saying, we finish on Friday, you say,
we have an 85% probability of finishing by Friday. It turns the schedule into what's called an S-curve of probability. It's just much more honest.
I love that. Okay, phase 5. Optimizing. We've run the numbers and, we have negative float. Or we don't have enough people. We need to fix the constraints.
Well, usually the problem is you don't have enough resources, people, or you don't have enough time. So first, let's look at resources. We've got resource leveling and resource smoothing.
They sound the same, but the sources say they are very, very different.
Resource leveling is the brute force method. You have Bike scheduled to do 2 things at once.
Yeah.
He physically can't do that. So the software just moves one of Bob's tasks to next week. However, and this is key, by moving that task, it might extend the project end date. Leveling cares more about Bob's capacity than it does about the deadline.
Okay. And resource smoothing.
Smoothing is deadline-driven. It says we cannot change the end date. So it looks for tasks that have float, that wiggle room we talked about, and it just nudges them around to balance the workload. It fills in the valleys and shaves off the peaks, but strictly within the existing time limit.
So smoothing is safe for the schedule, but leveling is safer for the sanity of your employees.
Ideally, yes. But sometimes you have to level, and then you have to deal with the delay.
Now, what if the deadline is the problem? We have negative float. We need to hurry up. The sources call this schedule compression. We have crashing and fast tracking.
This is a classic choice between money and risk. Crashing is trading money for time. You pay for overtime. You hire expensive consultants. You add resources to the critical path, tasks to just squash them down.
You're just paying to go faster.
Yes. Fast tracking is totally different. That is trading risk for time. You take tasks that were supposed to be sequential finish to start and you force them to happen in parallel.
Like pouring the foundation while the blueprints are still being finalized.
Exactly. It's incredibly risky. If the blueprints change, you have to rip up the foundation. That's called rework. Fast tracking is free in terms of dollars up front, but it carries a high risk of having to do things twice, which costs you even more in the long run.
Before we move to the final phase, there's an alternative method mentioned here that seems to challenge the critical path. The critical chain method, or CCM.
I love the critical chain. The critical path assumes the main problem is task logic. The critical chain assumes the main problem is resources and human behavior.
So it treats the project differently.
Completely. It strips the buffers away from individual tasks. You know how everyone adds a little safety margin to their own estimates?
Sure.
Critical chain takes all those little safety margins away, pulls them together, and puts one big project buffer at the very end of the project.
So instead of me hiding 2 days of safety in my task and you hiding 2 days in yours.
We put 4 days at the end of the whole project.
Yeah.
And we just run our tasks as fast as we possibly can. It also focuses on the dropped baton.
The relay race again.
Yes. In a normal project, if I finish early, I rarely tell you. I just sit there until the due date because of student syndrome. In critical chain, the culture is, I am done, here's the baton, go. It minimizes the downtime between the tasks.
Okay, we've built the perfect plan. We've optimized it. Now, phase 6, control and monitoring. The project is live. How do we know if we're winning or losing?
You can't just look at the calendar and say, looks good. You need earned value management, or EVM. This is the dashboard of the project.
And it gives us those acronyms that everyone fears on the PMP exam. Let's decode them. SV and SPI.
Schedule variance, SV, is simple subtraction. Earned value minus planned value. Are we ahead or behind in terms of the dollar value of work we've accomplished? A negative number is bad.
And SPI, the Schedule Performance Index.
This is your efficiency rating. It's a ratio. Earned value divided by planned value. If your SPI is 1.0, you're perfect. You are exactly where you plan to be.
And if it's less than 1.0?
If your SPI is 0.8, it means for every hour of work you plan to do, you're only accomplishing about 48 minutes of value. You're working at 80% efficiency. You are bleeding time.
Wow, that is a sobering number to see on a report.
It gets worse. If you are behind, you check the TCPI, the Two Complete Performance Index.
What does that tell us?
It basically asks, okay, you slacked off for the first half and you're running slow. How fast do you have to run now to still finish on time?
It's the catch-up speed.
Right. If your SPI was 0.8, your TCPI might come out as 1.25. And that tells the team, you have to be 125% efficient from today until the end just to hit the original date.
And that tells you if recovery is even mathematically possible.
Exactly. Sometimes the TCPI is so high, like 2.0 or something, that you realize it's impossible and you just need to ask for a new deadline.
And to visualize this, the notes mention burn-down charts and trend analysis.
Burn-down charts are great for agile teams, showing work remaining versus time. But trend analysis is the crystal ball. It uses that historical SPI. It says you've been 10% late every week for 2 months. The math says you will likely be 10% late next week too. It cuts through the optimism and shows you the likely trajectory.
So when we step back and look at this entire life cycle, from the constitution of the plan to the dashboard of EVM, what's the big takeaway here?
The takeaway is that a schedule isn't a static document. It's a living model. It balances the hard logic of physics. Concrete takes time to dry with the soft logic of our preferences and the chaotic psychology of Parkinson's law.
It really strikes me that this applies to everything. I mean, whether you're building an airport or just planning a wedding, you have a critical path. You have student syndrome where you end up writing your vows the night before.
Absolutely. Understanding these concepts allows you to kind of manipulate time. You realize that adding resources doesn't always help because of diminishing returns. You realize that lead time can buy you wiggle room. It's a framework for managing reality.
I want to leave the listener with one final thought from the sources, going back to that management reserve.
The unknown unknowns.
Right. We spend phases 1 through 5 trying to predict everything. We use Monte Carlo simulations to run 10,000 possibilities. We calculate SPI to 2 decimal places. But the system explicitly acknowledges that we cannot know everything.
That's the humility of project management. You can plan for the rain with your contingency reserve.
Yeah.
But you cannot plan for the thing you have never seen before. The management reserve is there because ultimately the universe is chaotic.
So the best schedule isn't the one that assumes everything goes right. It's the one that's resilient enough to handle when everything goes wrong.
Well said.